students, we are proceeding with the topic of differentiation, and today we want to look at stationary points. But before we look at stationary points, let's review the last topic on the tangent, the equation of the tangent and the normal, where we say if you have a curve, this is the normal, and this is the tangent. So, for example, in the equation of the curve is x squared plus 2x. If you want to find the equation of the tangent, assuming this is 0.21, the first thing you find dy dx, which is 2x plus 2. Then you find the exact gradient by substituting the value of x. So this will be 2 into 2 plus 2 to give us 6. Then you go ahead and you find the equation. You know gradient is change in y over change in x. So 6 is equals to y minus 1, x minus 2. So this is y minus 1 is equals to 6x minus 12. So y is equals to 6x minus 11. So that is the tangent. So my main emphasis is that the equation, the gradient that you get from dy dx is the gradient of the tangent. This is the tangent. Now to find the equation of the normal, you have to know that the normal is meeting the tangent at 90 degrees. So you just take m1, m2. So the gradient of the normal is going to be m1, m2 is equals to negative 1. So the gradient will be negative 1 over 6. The point remains to be the same point, 2, 1, and you get the general point, x, y. You go ahead and you find the equation. That one, we tackled it, and most of you have done the exercise. Is very good. But my main emphasis, the gradient that you first get from dy dx is the gradient of the tangent. The other one is the negative reciprocal of that. Thank you. Let's now come to our main lesson of today, which is stationary points, as you have seen here. So we want to look at stationary points. And stationary points are also known as turning points. They are also known as turning points. And there are three: it's either a minimum, or a maximum, or a point of inflection. We shall look at all of them. So we shall start with the example in the board here, where we have a curve whereby we have y is equals to x squared plus 2x plus 3. We are going to determine the nature of the turning point or the stationary point. Is it a minimum? Is it a maximum? Or is it a point of inflection? So to determine the first thing you find the dy dx, or the derivative. So in our case, our dy dx is equals to 2x plus 2. So we come at this particular point where x is negative 1, because this is where the curve is turning. We want to see how is the nature of the gradient at the turning point. So our gradient is going to be 2 into negative 1 plus 2, and you realize the gradient is 0. So the question was, how do you know this is a turning point? So at any turning point or stationary point or turning point, the gradient is always 0. So if you are asked to find the stationary point, equate the gradient function to 0, you will be able to find the stationary point. So my question here is, how do we know if this one is a minimum, maximum, or a point of inflection? So for you to determine the nature of the turning point, you go to the second derivative. This is the first derivative. This is the first derivative. So you go to the second derivative. That one will be the test for the nature of the turning point. So the second derivative will be d squared y over dx squared. This is the second derivative. So you differentiate the first derivative and you get it is 2 and this is positive. So if the second derivative is positive, then the turning point is a minimum. If the second derivative, that is, you have differentiated the first one and you find that it is a positive, like in our case, you can see the lowest point. The reason why it is called the minimum, it is the lowest point. So that one is a minimum and diagrammatically is represented in that manner. It is changing from negative through 0 at the turning point to positive. And you check the gradient at this point. For example, add negative 2, you substitute here negative 2, you'll get negative 6, negative 4 plus 2, the gradient here is negative 2. If you come at this point, for example, 0 plus 2, you'll get it is positive 2. So the gradient is changing from negative through 0 to positive. So the gradient, once the gradient is changing on a curve from negative, the gradient here we have found it is 0 to positive. That is a minimum point. That is a minimum point. So how do you know a point is a maximum point? So for maximum point or maximum, the second derivative, that is dy dx squared, if it is giving you a negative, if it is a negative value, that one is a maximum point. When the second derivative is giving you 0, that is a point of inflection. And what is a point of inflection? A point of inflection is whereby the curve is turning from positive to positive or negative to negative. And for maximum, it is turning in that manner. So this is a maximum point. So this is the test. So you go to the second derivative, that will be maximum point. So this is the most important thing to test for the maximum point. So for your assignment, I want you to test exercise 8.3, number 1 and 2. Exercise 8.3, number 1 and 2. So you test whether the point is a maximum or a minimum. Thank you and have a blessed afternoon.